Welcome back to the Turnaround Team Podcast. My guest today is Jerome Garot from Silicon Anchoring Systems. Jerome, I wanted to get you on because you had a post on LinkedIn a couple weeks back. I love the question, the 936 versus the 982. For the viewers that didn't get to see that post, you would care to elaborate on that for us a little bit?
Absolutely. So at the API, we're working on a new specification regarding refractory anchorage. This will be the API 984. And what I've seen, anchors being touched on in the 936 and the 982, I was hoping to see some people's opinion whether that was good enough and what is it missing, so that with the API, we can really kind of get a great coverage of everything people always have questions about regarding anchors.
Yeah, I got a lot of questions of them. Like I said, when we did the first podcast, I had a lot of questions about the technology, the machines, how long the leads could be to get the correct amount of power for the weld. But the question that got me was on the 936 and versus the 982, which it seems to be a helpful guide. The 982 does it to answer some questions that the 936 left out, and they're gray areas that it has. My only problem with the 936 is that it compiles the testing in with the inspection. I never understood why this happens. Throughout the years, there have probably been 40, 50 lab guys and ladies coming and going, but there's really no reason to get the inspectors to learn what a spherical bearing block is on a compression machine. They're like, what is that? That's a test question. And I've never understood why they compiled that in. So I'm hoping to see that maybe they clarified some of the inspection questions and take those out of the gray area. Maybe they could do something like that for the test.
I think that's quite clear, because what they probably did with 936 is they probably wanted to focus on one thing, and they thought it was just too little because there's nothing else. So what you're mentioning is probably a great topic to bring up at the API, because inspection standards weren't good enough for reviewing refractory, so they came up with 982. And then so some of the things in 936 may become redundant. And the great point that you brought up, maybe the same thing for lab stuff. Maybe that should be out and in its own spec. And that way you can kind of segment your specialties without having to, teach a fish how to fly and kind of confuse people who don't need to know certain information, but can always refer to something when they need to know it.
Yeah, that's exactly my thought. And if they were to separate that, like I said, there's not that many of lab guys, lab people, personnel in the U.S. anyway. I don't have no idea how many are in Asia and on the other parts of the world. But I know definitely Mike LaValle over at CFS would love to hear that, they're going to separate if they were separate the testing from inspection. So you travel around with your team, and you're doing the anchoring inspection installation, are you not?
Yeah, we're doing the anchor installation, a lot of consultation on pre-turnaround as well, because it's kind of just like a lack of sharing data around the world. And so we'll typically be brought out, we turn around, explain a little bit about anchors, kind of tell about our strategy. In Asia, we do the surface preparation and the anchor removal. In Europe, we do the installation and the supervision. And kind of North America, we focus mostly on supervision only.
Okay, so it's been, from what I've seen and heard of Silicon, like I said, I'm not really involved. I'm more of a lab type person. I'm not really out in the field doing inspections, which I'm trying to get into. If they would ever let me out of my doghouse here, I would definitely love to go out in the field and look at some of this stuff. But it's been about 7 to 8 years since I've been hearing about it. What have you seen as far as, from the time that it was installed to what you're seeing? You come back the second time, third time. How's the anchoring systems holding up?
I think the most important part is kind of realizing, specifically with the abrasion system anchoring linings, is that the focus should have always been on the refractory materials, because the refractory materials that are used in the abrasion resistant linings, like your AA22s, your ActChems, your Thermbond 12Ls, those are damn good and expensive materials. And I'm not a refractory expert. What the one thing I know about refractory is that you're not supposed to have cold joints. You're not supposed to have interruptions between refractory. I'm glad you're nodding your head, so I know that's right. And hex metal, the issue with hex metal is that it is not a monolithic, it's a multilithic. The fact that it has a barrier between the refractory at every cell. And now with our products that kind of allow the refractory to be continuous, we see that the refractory was the most important part from the get-go, and it allows the refractory to do what it's best at and protect the steel. And so the anchor, the hex model got in the way of that, and with the speed hex we wanted to let the refractory shine again. And what we learned beyond that point is that the metallurgy is so incredibly important. The way the refractory and the metal behaves, the most important part is getting the right metal combination on the weld side to actually allow it to survive the crazy thermal shock it goes through during startup and shutdowns.
Yeah, that's definitely. So I was curious to get your opinion on the 982. I know you said that you just got it. You were just reading through it. I went through all of our field inspectors and asked them what they think about it. I haven't found anybody who could disagree with it. I mean, one of the guys was saying that it's a good thing. It's a great thing for them because it's going to separate the real inspectors from the wannabes that are trying to get into the industry and not learning anything, and they're really causing a ruckus. So it's going to separate that. It answered a lot of different questions for them, like again with the gray areas that the 936 did not. So I'm curious to get your opinion.
Yeah, I mean the 982 looks like it's really practical because it kind of gives some visual medium and some real keynotes to actually reference, because otherwise it's really just up to somebody's opinion. And I think in the West it's doing really good, and people are using it like a good guide. But the one thing I think is quite unfortunate is that the speed of how this progresses around the world is very slow, because I've spent now the last year, probably half of it pretty much in Asia. They've never heard of 982 anywhere, and so they're all 936, and so I'm hoping that will still make it around the world, but I'm a little bit hesitant that maybe some of the experts in Asia are not going to be taken serious in the West, even though that they've been doing their job for 30, 40 years too. But overall, 982 looks like it's really what it's supposed to do. It's supposed to really tackle refractory linings. I'm just a little bit worried about the anchor part in that, because I did review it, and I don't think it is doing enough to character that part of a lining.
So again, but this is going to be that all the anchoring is going to be covered in the 984, if I'm not mistaken. Like I said, I'm not really involved with the development of that particular specification. But from what I'm seeing from comments online, on LinkedIn, Facebook, all those other social media places, is that that's going to be covered in the 984. But again, since the rest of the world hasn't really seen this 982 or the 936, as you're saying, I would love to get the API committee on this podcast, and just so they could be able to tell their story and be able to push it around. I mean, I don't know how far the reach goes on this podcast. It's not yet. It's pretty new, but at least they'd be able to. They have a platform to tell their story, talk a little bit about the specifications, why they developed them, how they're helping the industry, and where they're going to go forward.
I mean the API 936, that one is pretty well established around the world. It's the 982 I haven't seen referenced anywhere yet, and I guess that's really up to the designers and the spec providers to let that trickle out. But the part that's really, sorry, I forgot what I was going to say there for a second. I had some notes here. Oh yeah. So way the API is valuable is quite notable, because anywhere you go around the world, they're always waiting for some input from an American licensor, an American refractory manufacturer, an American this and American that. So the API, I mean, really kind of shows the stage for what the excellence in the U.S. has created. And that example, I think for the API, it's really a good party to actually also present that. And how they do that, I'd be very curious to hear from their side, because I don't know how it makes it from an API spec from a little room with 40, 50 people into global applications. So I'd love to hear that from their side.
Yeah, I mean, like I said, I've never actually attended one of the API meetings. I mean, people ask me all the time, "Are you going to be at API this year?" I'm like, probably not. I have no reason to be there. But this is a great reason for me to maybe go ahead and go out there and stick a camera in someone's face and ask them a question. I hate to bombard people and be rude, but I mean, if this is the only way we're going to get answers, it's the only way we're going to get them. But I know that Jackson, the owner of TSG, I know he goes to every single one of them, and he's always talking about it is about that. I guess 40, 50 people, and they're the best minds that we have or globally, because there's members that are not just American, they're global. So and they come up with all this stuff. In a way, it's kind of our job is somewhere in the middle range. We're not way up high as an engineer. We're not really way down low as a labor. Somewhere in the middle, it's kind of our job to reach out and go, hey, this is a problem here. I don't really know which way to go because this is not specific to what I need to do. Maybe just reach out and just let them know and let those big brains of theirs go to work and see what they come up with.
I think it's kind of funny that you said it because, in many things in the world, you can kind of engineer it out. But the way the turnarounds and specifically refineries and refractories work, I mean, you have to have exactly the guys that show up at the API to solve these problems because the typical engineers in this field, they work with refractory maybe once every 5 years on the turnaround. They don't stick around. It's not something they can do 24/7. So it's an underappreciated, undervalued specialty. That is, if it was gone, refineries would not survive at all. And so, yeah, I mean, I was speaking at the API in last API in November, and I was a little bit starstruck just by everybody who was in the room. And I mean, like you said, they are absolutely the best minds to be able to solve this problem. But it comes from the practical experience of actually having done it in the field. Because I mean, an engineer is they can think about it, they can theorize the problem, but until you've seen it, it's just it won't be real for them.
Yeah, that's exactly how it's going to go. So if I could get you to grade the 980C from 0 to 100%, what would you give it?
I'll give it an 82, maybe. I think it does a damn good job. And look, I mean, they spent a lot of time in it, and it's I think the first or second edition. So I think it has some room to grow, and I think everything should have a little bit of room to grow. So 8.2, I think, is a damn good score, and it's doing a good job. So overall, I think you guys would call that probably an A- in the US.
Yeah, we definitely would call it that. Do you have any? You want to give the 936 a grade?
I think maybe the results that the people that come out of using 936 is anywhere from a 2 to a 10. So the 936 will probably have to be graded somewhere. Probably for new builds, it's probably like a 7 to 8. But for turnarounds, I think it's a 3 to 5.
Okay, all right. Well, that's percentage?
Sorry, 30
Okay.
to 50.
30 to 50. Okay, I got you. Yeah. This is our metric and standard going at each other over here, I guess.
Yeah.
So you guys have any? I mean, outside of what you said, the SpeedHex 3 is the newest product. Is that correct?
No, SpeedX3 is actually kind of ancient now in refractory terms. It's over a decade old. It's done a damn good job. Right now we're looking at the next iterations. We got the SpeedX 6. We have SpeedX 9 coming up as well. So there's some natural conclusions in how you develop them. Not every single one is going to go into the same application. And of course, there's a lot of other really exciting stuff we're working on because the moment we stop innovating is the moment I really get bored. So always got to find something new to solve.
Yeah, that's one of the things because we're not just a refractory lab. It's here at the office. I mean, you do inspections. They do their 360 cameras. They do all kinds of craziness out in the field. But we don't just test refractory here. We also make the refractory plexiglass molds. And we're always trying to innovate. When we do material demonstrations for manufacturers, we build all of the things that they need to do that. Whether that's a 4 foot by 4 foot hex with plexiglass on the back, so they can gun material into hex, or if they need a what's called a mousetrap, where you could just demonstrate your self flowables. We build all that, and we're always trying to innovate with new systems to make the refractory testing a little bit faster, a little bit better. Take out the human error that may be built into some of that. and just get rid of it through systems. So we always have to innovate. And what my favorite thing to say is, if you're not getting better, you're getting worse. So I definitely understand what you mean by that.
Absolutely, I agree.
All right, so right now, Turnaround Specialty Group is offering a 20% discount on all shoebox sample molds when you use the promo code podcast. So make sure when you put your order in, when you email in, or you call in Jackson, or you call in myself, you need shoebox molds, use the promo code podcast to get your 20% off.
Okay. Well, I'll give you a chance to make any closing comments that you need to make.
No, I'm just really excited. I mean, thanks for having me on. I'm looking forward to people being participatory in this, because the 984, it's a collaborative effort of really, really great people, competitors and friends alike at the API. I think anybody who's been critical about 936 or 982 about anchors, take that criticism, throw it at us so that we can make the best damn spec that we can. So that's the stuff we're working on now. We'll have the next session next week. I'll be flying out to San Fran for that. And on the other things for us at Silicon, we just opened up Silicon Arabia in Saudi Arabia. So that's exciting. We're kind of bringing Silicon closer to where the markets are. And then the next few years, we're hoping to do something similar in North America after we've really kind of, reinvented ourselves and given a chance at, building something like my dad built Silicon from the startup. Me and my sister wanted to have a chance to do something similar in other places in the world. So that's exciting news for us in the next few years.
His story was really good. I had to ask him about it because his story is widely available online, pretty much everywhere. You just search Silicon, and it's videos of him telling the story. And I had a lot of questions because I came across a video of him saying that he was developing all these things in his garage, and then everything was 220 volts or 230 volts, and it wasn't 110 like he was thinking. He had to reinvent everything. I was like, man, that's what we run into all the time. It's like you have a great idea, you start running with this, and all of a sudden you got nothing but problems. And but to be able to bounce back from that, have such a great success story, it was just one of the best stories I've heard in a while.
Yeah, it's nothing but impressive. So kudos to my dad. I mean, he's just through every barrier that came out, he just keep trucking, and to still keep such a high mood. I mean, it would have turned me quite sour, honestly, after all that, when you're just starting out by yourself. But now we've got an organization of 100 to 150 people that all stand behind him and kind of want to share his vision as he's taking a step back, going into retirement, driving his motorcycle everywhere. I think so. We're honored to kind of keep that vision alive and that spirit alive.
Yeah. Well, I'm definitely glad to hear that the next generation is taking over and wanting to innovate. I can't wait to see what you guys bring us. So I really want to thank you for joining me today, and I hope that, like you said, we get some good feedback from this one, and maybe we can do it again.
Yeah, I was definitely looking forward to a good panel. It'd be good.
Okay. Well, thank you very much. I appreciate it.
All right, man. Thanks, Craig. Good luck with everything.
Thank you.
See ya.